Last year, a few days before Christmas, my co-founder's brother-in-law decided to take a deeper look at this stomach pain he had been suffering for almost 3 months. At the beginning, the doctors thought that it was an ulcer because of stress or working too hard. But since neither medication nor changing his diet was working, that day they decided to do a biopsy. And a few weeks later, the results of the biopsy came back. It was a stage 4 stomach cancer. At the time, he had just opened his wine bar, and he was being featured in several magazines about how he was going to revitalize the wine industry in his country. At the time, he was only 28 years old. And I believe at that age, people should be worrying about creating an impactful and successful future rather than worrying about having a terminal disease growing inside you. Today, to get diagnosed with cancer is a stressful and frustrating process of going back and forth with new tests, different doctors, describing symptoms, discarding diseases over and over. And that is the way cancer diagnoses have been done since the beginning of history. And that is important because 1 out of 3 people in this audience will be diagnosed with cancer, and 1 out of 4 will die because of it. Today, we have 21st century medical treatments and drugs to treat cancer, but we still have 20th century procedures and processes for diagnosis, if any. Today, most of us have to wait for symptoms to indicate that something's wrong. Today, the majority of people still don't have access to early cancer detection methods, even though we know that catching cancer early is basically the closest thing we have to a silver bullet cure against it. I believe we can change that in our lifetime, and that is why my team and I have decided to begin this journey. This journey to try to make cancer diagnosis at the very early stages and the monitoring of drug response at the molecular level easier, cheaper, faster, and more accessible than ever before. The context, of course, as Patty said, is that technology is disrupting our present at exponential rates, and the biological realm is no exception. It is said today that biotech is advancing at least 6 times faster than Moore's law. But progress in biotech is not only being accelerated, it is also being democratized. Just as personal computers or the internet or smartphones level the playing field for entrepreneurship, politics, or education, recent advances are leveling it up for biotech progress as well. And that is allowing that multidisciplinary teams like ours try to tackle and look at these problems with new approaches. We're a team of scientists and technologists, and based on recent scientific discoveries, we believe that we have found a reliable and accurate way of detecting several types of cancer at the very early stages through a blood sample. We do it by detecting a set of very small molecules that circulate freely in our blood called microRNAs. To explain what microRNAs are and their important role in cancer, I need to start with proteins. Because, as you might know, when cancer is present in our body, protein modification is observed in all cancer cells. Proteins are large biological molecules that perform different functions within our body, like catalyzing metabolic reactions or replicating DNA or responding to stimuli. But before a protein is expressed or produced, relevant parts of its genetic code present in the DNA are copied into the messenger RNA. So this messenger RNA has instructions on how to build a specific protein. And potentially, it can build hundreds of proteins. But the one that tells them how many they can build and when they can build them are microRNAs. So microRNAs are small molecules that regulate gene expression. Unlike DNA, which is mainly fixed, microRNAs can vary depending on internal and environmental conditions at any given time, telling us which genes are actively expressed at that particular moment. And that's what makes microRNAs such a promising biomarker for cancer. Because as you know, cancer is a disease of altered gene expression. It is the uncontrolled regulation of genes. Another important thing to consider is that not two cancers are the same, but at the microRNA level, there are patterns. Several scientific studies have shown that abnormal microRNA expression levels varies and creates a unique specific pattern for each type of cancer, even at the early stages, reflecting the progression of the disease and where is it responding to medication or in remission, making microRNAs a perfect, highly sensitive biomarker. However, the problem is that we cannot use our existing DNA-based technology to detect microRNAs in a reliable way, because they are very short sequences of nucleotides, much more smaller than DNA. And also, all microRNAs are very similar to each other. So imagine trying to differentiate two molecules, extremely similar, extremely small. We believe we have found an accurate and very easy to use way to do so. Let me do a demonstration. Imagine that next time you go to your doctor and do your next standard blood test, a lab technician extracts the total RNA of your blood sample and puts it in a standard 96 well plate like this one. Each well of these plates has a specific biochemistry that we designed that is looking for a specific microRNA. And when the microRNA is present in the sample, it's acting like a trap that closes only when it's present. When it does, it will shine with green color. To run the reaction, you put the plate inside a device like this one. We call her Miriam. And basically what it's doing is creating the correct luminosity and heating conditions for the reaction to happen. Now, can we change to the smartphone? Hello? Can we change to the smartphone? No? Okay. Should I wait? Or can we put the camera here? Yeah? Okay. So let's put the camera. Okay. So basically, to document the reaction, you put your smartphone on top of it. I wish you can see this. The smartphone is taking pictures. Well, we can play around with this later after this. The smartphone is taking pictures and sending those pictures to our servers for processing and interpretation. Basically, what it's doing is measuring three parameters: which wells are shining, how much are shining, and how fast are shining compared to a positive and a negative control. And then, once the reaction is over, it will show a chart with specific microRNAs present in these person's samples. And then we take that unique pattern and compare it with existing scientific documentation that correlates microRNAs patterns with the presence of a specific disease. And we'll be around to play around with it, but these are real samples for we detected breast cancer. Another very important aspect of this approach is the gathering and mining of data in the cloud, so we can get results in real time and analyze them with other contextual information. If we want to better understand and decode diseases like cancer, we need to stop treating them as acute, isolated episodes and start considering and measuring everything that affects our health on a permanent basis. This entire platform is a working prototype. It basically uses state-of-the-art molecular biology, a low-cost 3D-printed device with off-the-shelf electronic components, and data science to try to tackle one of humanity's toughest challenges. Since we believe early cancer detection should really be democratized, this entire solution at a working prototype level is already 50 times less than current available methods. And also, we're working on a new version of the device that will not need a smartphone anymore to document the reaction. It will do it by itself. We will have it ready in 2 more months, and when we do, we want to involve the community into helping us accelerate this even more. So we're making this open source by December 2015. Let me say very clearly that we are at the very early stages. But so far, we have been able to successfully identify the microRNA patterns of lung cancer, breast cancer, pancreatic cancer, and hepatic cancer. And currently, we're already working with the German Research Cancer Center and 200 women doing a clinical trial for breast cancer in Heidelberg in Germany. This is a single, accurate, non-invasive, easy to use, and affordable test that has the potential to dramatically change how cancer procedures and diagnostics have been done. Since we're looking for the microRNA patterns in your blood at any given time, you don't need to have any symptoms. You don't need to know which cancer you're looking for. You only need 1 milliliter of blood and a relatively simple array of tools. Today, cancer detection happens mainly when symptoms appear. That is a stage 3 or 4. And I believe that is too late. It is too expensive for our families. It is too expensive for humanity. We cannot lose the war against cancer. It not only costs us billions of dollars, but it also costs us the people we love. I'm sure everybody here has a story, a close story, of someone that has fought or is fighting bravely against this disease. However, I want fights like this to become very rare. I want to see the day when cancer is treated easily, because it can be routinely diagnosed at the very early stages. And I'm certain that in the very near future, because of this and all the other breakthroughs that we're seeing every day in life sciences, the way we see cancer will radically change. It will give us a chance of detecting it early, understanding it better, and finding a cure. Thank you very much.